Hello everybody, welcome back to the workshop. Today we're going to be working on grinding a lathe tool by hand. Often these days everybody seems to use carbide inserts and you've got to keep throwing them away and not have the right one or something, but it's actually quite easy to grind a lathe tool out of high-speed steel. It's not as though we're going to be working at production speeds or that kind of thing, so we can take our time with stuff and make a nice tool. This demo I've cut out of wood here just shows you all the different angles that we'll need to recreate on a piece of high-speed steel. Here's an example of the high-speed steel that we'll be grinding up. It's fairly small and pretty hard to point to, so I'll just show you what the wood is and we'll go from there. This tool is designed, or a tool of this shape is designed to cut in that direction, so moving to the left like this as you're turning, or going straight in like that as you're facing off. And this is called a right hand tool even though it goes to the left. Don't know why, it just is. So basically the first angle that you'd cut or grind onto a tool is the one on the front here. That gives you clearance back this edge so that when you're cutting, only the point of the tool touches the work. So this bit back here is clearance, and this edge here is your cutting edge. If, well actually no, this edge is your cutting edge if you're turning this way, and if you're facing off this way, then the front becomes the cutting edge. Clear as mud. Our goal is to end up with an angle on the front here that's slightly less than 90 degrees. That way we can use it for both turning and facing. If it's more than 90 degrees, you can use it for one or the other, but not for both, because you can't make a square corner basically. So we've got an angle this way, and if we turn 90 degrees, we've also got an angle that way. So it's a compound angle when you look at the front of it. It sweeps back this way and down that way. So this angle down here is a clearance angle as well. If you look at the side of the tool here, we've cut it back a bit that way. Where's my pointer? We've cut it back a bit this way, so that gives you a they call that the lead angle. This one is the trailing angle, and this one is the leading angle that way. And facing down this way, we've got clearance there as well. Looking at it from the front, you've got a clearance angle on the side. These angles aren't exactly critical. I've made this at about 8 degrees here, there and everywhere. Different metals, you can use different angles. You can find a chart for it. I'll just stick a chart on the screen now. And you can see here there are different angles and different dimensions depending on what metal you're cutting. But I find that for most metals, except for probably brass, you can get away with the same angles. So that describes the two clearance angles, this way and that way. Now if you're looking at the top face again, you can see I've cut it back this way, or look, maybe better off looking at it that way. Cut it back this way, and from the side it's also facing back that way. They're your rake angles. So as you're turning, the chip comes off the work and hits this face, and it basically travels in this direction away from the work. And so if whether you're cutting in like that on a facing job or turning like that, the chip is going to head in the same direction away from the job. And the only other feature is this little radius on the nose here. If I had a sharp corner on the point, it wouldn't take much to burn that away as soon as it got hot. So you put a bit of a radius in there, and how big a radius you make depends on the requirements of your job. You might want a fairly sharp corner, or if it's taking a bit of impact or something, you might want a fairly rounded corner to absorb the load. Anyway, that's a design question. You make your tool to suit whatever the design requires. So, and the other surface, this one here, and the bottom, you never need to touch those because we're traveling in this direction. So it's this face, and this face that we grind back, and the only pieces that ever touch the work is this edge and that edge, and of course the little radius. When you set your tool up, if I can figure out how to hold this so you can see it. When you set your tool up, you're going to set your point on the center of the spindle. So there's the center of this little piece here. You set the edge of the tool up on the center, and you can see here how that clearance angle here means that the only piece that's going to touch the work is the edge. If I have my tool above center, you can see it's exaggerated. It's going to touch back there somewhere and do nothing. So right on the center height there. And then you've got to, then your clearance angle takes effect. If you're doing facing work like that, your tool's going to be coming in this way, like that. So then the other angle down the bottom there provides your clearance so that only the edge of the tool takes the work. If you've set up your tool so that it's less than 90 degrees in this angle here, then you won't have to move your tool when you face off. Then you come around here and turn. You won't have to move your tool because both of these here provide clearance on the work, and only the point will touch, or the cutting edge will touch. Make sense? All right, probably enough gibber. Let's get on and grind a cutter or a tool out of this little piece of high-speed steel. This is 1/2 inch square, and when you buy them, generally speaking, they have an angle already ground on the front, and you can use that as a starting point. All you've got to do is, when you buy a piece of high-speed steel, make sure that it's going to fit in whatever tool post you've got on your lathe. This lathe here will hold up to 5/8 of an inch. But yeah, the bigger the tool, the harder it is to grind because you've got more steel to remove. Anyway, hope that's clear. Let's go over to the grinder. Lost a bit of footage there. I'm not sure what happened. I think I ran out of space on my memory card. Anyway, just make sure you've got your wheel dressed up nice and smooth. You can have a look in the link on the previous video of me sharpening a drill, how to dress the grinding wheel. You just need one of these carborundum dressing sticks and just move it across the front there. Anyway, have a look at the other video. That'll show you how to do that. So when you're grinding the front, you just hold it up like this and across like that, and just move across the wheel back and forward as you're working. Get a piece of high-speed steel without any cobalt in it. If you're grinding cobalt, it takes forever. So if you're just machining mild steel or softer stuff, you won't need cobalt. So we'll just move back across there, like that. And you can see I've got a nice even surface on there now. The next thing to do is the side, like this. And you'll end up with a nice even surface down there like that. That took me about 5 minutes to do the front face and the side face. You can see there, this bit down here doesn't matter, that's just clearance. But I've got a nice edge along there and a nice edge along this side. And the next is to grind the 2 rake angles. So we'll come at that from the top like this, but we'll hold the tool back that way and up this way to get the 2 angles that we want. So we're starting right back up here. You don't need to go crazy, about 5 degrees both ways is enough. Don't let it get too hot. You don't need to gouge it all out at once. You can see there we're sneaking up on it, so it's cutting back that way and back this way. You know when it's getting hot because you can't hang on to it anymore. Getting closer. You see I've got a little flat up here still on the edge. Alright, that's got it now. See I've got a nice face on there. There's no little flats or edges or funny edges or anything. Now we'll just do the nose radius, and there's not much in it. We'll just touch it on the tip and then I'll flatten it out later on with a stone. I think that'll do. You can see there now that I've just put a little radius on the point, and I'll touch that up with a stone, and then we'll get over onto the lathe and cut something with it. I've always used this little oil stone for that kind of thing, but these days I've got a couple of diamond hones as well. There's a fine and a super fine, and that's enough just to shine up the cutting edge. So you come at it like this, just hold your stone flat against it, don't rock it up over the edge or you'll take the edge off. Like Mrs. Shed's home. And we'll do the nose radius as well. Doesn't take that much. You'll see there, it just shines up a little bit. Whether you can pick it up. I'll do the front face as well. Anyway, let's go over to the lathe. Alrighty, you can see these two tools here. There's my new one and my old one. You can see it there. And I've been sharpening that and regrinding it for quite a few years. So you can just keep on sharpening it, keep on using it. If you're careful how much you take off, and it'll last a long time. Now I'll just grind the end off and I can make another one. You can see it's a little bit shorter. I think I bought both those bits of steel at the same time. So I'll just ground that off now and start again. But here's a new one. We'll just set that up at center height. This lathe is exactly 5 inches from the surface of the bed up to the center of the spindle. I'll just measure that with a ruler. Closer you get it to one center, the better it's going to work. There we go. I'll just see what speed I've got that set to. Make sure nothing's going to fly out at me. I'll just put some oil on the spindles. on the spindle bearings, I should say. Just a couple of little cups there you fill up. Go a bit faster than that. I'll do a video in the next few weeks where I show you how to calculate what speeds to use with different materials. That's pretty close, maybe one faster. You kind of get a feel for it after a while, but it's easy when you're starting off to think you know what you're doing and you don't. It's easy to do that when you're old as well. First of all, I'll just set the angle of the tool so I can cut both along the diameter and the face of the job. So with the chuck there, that's in the frame there, I'll just come in now. Can't quite go back far enough. Till it's not quite touching there. So now I've got a bit of side clearance, and if I come in directly towards the workpiece here, I should have a bit of front clearance as well. Like that. So now I can lock that. Bumped it. And that should give me a bit of clearance both on the side of the tool and on the front of the tool, so I can turn and face. Now I've made something else with this bit of steel, and there's just a dimple there from the drill last time I used it, so we'll just take that off. Whoops. I'll also do a video on how to solve chatter, which is what you heard just then. That's cutting all right. I'll just keep going now until I've faced that right off. Stick a bit of oil on it, give it a fighting chance. Sometimes you'll get a better finish if you cut coming out backwards. It's because it's taking a more gradual cut across the surface. We'll just do another one like that with a bit of oil on it. Yeah, so that's got that faced off. What I can do now is, let's just cut a bit along the diameter, just because we can. Prove that it worked going in the other direction. Just touch it off on the diameter. So we'll give it about 5 thou. I don't have my feed turned on at the moment, so I'll just have to feed it gradually by hand. So that's cleaned up all the way around. Surface finish is reasonable. And the only other thing you'd normally do when you're turning is we'll take that sharp edge off there. This is my chamfering tool. It's kind of like a one-sided drill. It's good for doing internal diameters and outside diameters. So if you'd like to see how I ground up one of these, just let us know in the comments and I'll do a video on that as well. It's already set to center height, so I don't need to worry about that. I'll just set it square there. And you just give it a touch on the edge. Like that. And if you really wanted to be special with it, or you wanted it to look nice, you can just get a piece of wet and dry. This bit's fairly blunt already. Never be tempted to check for a sharp edge with your finger while it's spinning. It's the best way to cut your finger because it's like a razor blade. Never get a rag near a rotating part as well because it'll just grab it and pull you in with it. Anyway guys, I think that was a successful test for that tool. We can see here that we've got a nice finish on both the end and the diameter, and a nice little chamfer on the edge. So I think we can call that done. Let us know if you want me to show you how to make that chamfering tool. There you go guys, that's how to grind up a simple turning and facing tool. If that's the first tool you have in your kit, then you're off to a great start. Thanks for watching. If you like this kind of thing, don't forget to give us a like, and if you want to see more like this, do a subscribe and turn the bell on, and we'll see you on the next one. Can't really see you. Wait. Take it. Wait. Take it. Good girl.